Today we are going to learn writing chemical formula of compounds. Valence electrons. For that we need to learn valence electrons and what is a chemical formula. So a chemical formula is basically representation of the compound in such a way that it gives us the actual number of its constituents in it. For example, that gives number of constituents in it. Alright, so let us say carbon dioxide, for example. This is the molecular formula which tells us that there's one carbon atom in carbon dioxide and two oxygen atoms. Or let us take ammonia, 3 hydrogen, 1 nitrogen. Alright, so for that we need to know what two concepts: the valency of an element and the valence numbers. Okay, valence, so valency of an element is defined as the combining capacity of that element. It is equal to the number of hydrogen atoms or the number of chlorine atoms, or double the number of oxygen atoms with which one atom of the element combines. For example, consider NaCl, sodium chloride, or common salt. So this is Na plus Cl minus. So this thing Na combines with one chlorine atom. So this, as we know, it is equal, valency equals number of chlorine or oxygen, double the number of oxygen, 2 into number of oxygen or hydrogen the element combines with. The element combines with. So to find the valency of electropositive elements, we find the number of chlorine or 2 times the number of oxygen or hydrogen molecules the element combines with. So to find the valency of sodium, we find the number of chlorine atoms, the number of chlorine, alright, just change the color, number of chlorine atoms sodium combines with. So we know that sodium combines with 1 chlorine atom. So hence the valency of sodium is 1. Alright. Similarly, this is true for all electropositive elements. So we find it this way. Alright. Or take another example. Let us consider magnesium chloride. To find the, we know that this is the electropositive thingy, this is the electronegative thingy. So chlorine is, we know, electronegative, which I represent in pink, and electropositive, magnesium, I represent in blue. So to find the valency of magnesium, we find the number of atoms of chlorine magnesium combines with. So magnesium combines with 2 chlorine atoms. So valency magnesium of magnesium is equal to 2. That is the number of chlorine atoms it combines with. So this is the valency of an element. Finding. Alright. So now let us find the valency of electronegative electronegative ions. Okay, let us say negative ions. So they may be bivalent, trivalent, or monovalent in nature. So they are listed according to that. Alright. So here we have I'm so bad at this. Sorry. Okay, so we have monovalent, chlorine, bromine, iodine, or I think we should just move on to the next page. I'm so sorry. So this is for electronegative. I'll write it again. Okay, monovalent. We are going to arrange them according to chlorine, bromine, iodine, hydroxide, nitrate, or permanganate. Okay, or they can be, let us differentiate them according to color so that it is easy to remember, or it can be bivalent. Sulfide, oxide, carbonate, or okay, and so on, or even sulfite for that matter. Okay, this is sulfate and this is sulfite. Okay, and then we have trivalent stuff. So let us, okay, no space for trivalent. We have nitride, phosphide, phosphate, or borate. Alright, so this is the list. Now, formulae of ionic compounds. So ionic compounds are basically compounds formed by a positive ion and a negative ion. Okay, positive plus negative. The classic example we give is again our common salt, sodium and chlorine. Okay, and the reaction is given by sodium hydroxide plus HCl. This is a base, this is an acid. They neutralize each other to form a salt and water. So okay, let us alright, so sodium, that is the positive ion, combines with the negative ion chlorine to form NaCl, and these combines with this the negative and the positive thing form water, and this is the neutralization reaction, and this is called a ionic compound. Okay, now see, this is called an ionic compound, Na plus Cl minus. So let us see how we know that. But why not Na2Cl or NaCl4? Why not? Why NaCl is the question we face. So let us derive it. Alright. So we derive it by the crisscross method. But before that, we don't want to mug up stuff, so we are going to do it our way, and then we'll move on to the crisscross method. Okay, sorry. So Na, it's the positive thingy. So let us draw its electron structure. We know its atomic number is 11. Okay, so this is the K shell, L, and let us see if we need KL. This is M. So the K shell has 2 electrons in it. L has 8. 1, 2, 3, 4, 5, 6, 7, 8. And so this is 10. And this has an atomic number 11. So the last one goes to the M shell. So this is Na structure. Going to the negative radical, chlorine. Has a atomic number equals 17. 1, 2, 3, 4. Let us see. So K has 2. 1, 2, 3, 4, 5, 6, 7, 8. That is 10. 1 second. Alright, excuse me, 10. And this is 1, 2, 3, 4, 5, 6, 7. Okay, so this is 2 plus 2, 10. This is 7. Alright, so we don't need the last shell. Just erase it and woohoo. Alright, so we have 2 in here, 8 and whatever. So this is at 17. So moving on to the next page, let us draw something more clear. Okay, NaKlM 2, 8, 1. Z equals 11. Let us draw a similar thing for Cl. KLM Z equals 17. Z is the atomic number. So this is 2, 8, 7. Now, to form a duplet or a stable atom, sodium needs to remove one electron, because either sodium has to gain 7 or lose 1. Okay, this is it. And with chlorine, it is something like this. It has to gain 1 or lose 7. So it is easier to lose 1 than to gain 7. Alright. And here it is easier to gain 1 rather than lose 7. Okay. Isn't it? What sounds logical? Obviously. This sounds logical and this sounds logical. So this thing has to remove 1 and this needs 1. So these two, these lovebirds combine, because see, this needs to give off 1 electron and this needs to take 1. This needs to take, this needs to give. So this satisfies, the both of them. So what happens is, the two of them combine to form NaCl. So, where Na forms a positive radical because it loses 1 electron, and this is negative because it gains an electron. Alright, so this is pretty much all about the concept. Alright.